So we create a new file. We create a new file. Let's call it intro to OOP. If you want to separate your the words, use underscore intro to OOP dot that. So okay, hold on. And I'm thinking of creating a separate folder for OOP. So you know what? If you can see my mouse now, you see I'm moving around this first icon. The second one is to create a folder. The first one is for a file. Second one is to create a folder. So I want you to click on that second one and name it OOP. And press enter. OOP. Then I want you to drag that file that we created just now, that intro to OOP. Drag it inside that folder. If they ask you anything, just click on yes or move. So if you've done that, let me know, please. Have you done that?
Yeah, .dat.
Yes, that has to be .dat. But if I'm naming the folder, you don't need to put .dat. It's just a folder to keep our OOP code. I want to separate it from the rest that we've done. So the session will end soon, so you can just join again ASAP, please. So can I continue?
Yes.
All right. Let me get to it. So, hold on. I want this one to load first. All right. So before I type any code, I just want to let me just specify some things. OOP stands for Object-Oriented Programming. So OOP is just a programming paradigm. Yeah, there are other programming paradigms. We have functional programming, procedural, and all that, and then we have OOP too. So it's just like a style of writing your code, just to organize your code. That's just it. It's just to organize your code. So the Dart programming language is a true OOP language. It's a true object-oriented programming language. What do I mean by that? All types and objects inherit from this object class. We have this generic class called objects. That. So everything, you know, I've been mentioning this since the beginning. When we have integers, we have strings. When we said, hold on, we have the int type, int data type. We have the string data type. We have double. We have Boolean. We have all that. All this inherits from the object class. When we get to inheritance, you get to know what inherits means. So, but for now, just know everything inherits from this object class. So the reasoning behind this OOP is just to model everything you see as objects. So everything you see, you can model them as objects. Like now, for instance, a person, you can model a person as an object. So you can say, yes, a person has a name, a person has all these nouns, has a name, has maybe a person is dark, a person is all that, just all these nouns. Person has, we call them properties. So a person has all these properties. And then the person can also create some actions. In programming style, we call them methods. So these are like the verbs that you perform on an object. So let me go back to this. So this is my person. You can see. So this is like a generic term. This is a person. Let's say this is a person class. Then the person can have a name. Yes. The person can have an height, can be tall or short and all that. And then the person can also do some sort of stuff. The person can run. The person can swim and all that. So with this person class, we can now create instances we can create different instances from this person class. Let me break it down. So let me say I want to create a person. Let me say I want to create me from this person class. Me as in me, Jamming. I want to create me from this person class. So I can create me because I said the person can have a name. So now I can instantiate this person class as Jamming and then supply the name. You can say, yes, the name for this instance is Jamming. The height is, let's say, 1,000 centimeters. And then, don't laugh at me. And then the person I can say, Jamming now can run, right? Jamming now can run. Jamming can swim. So it's getting all the properties as soon as you instantiate the object. Let me interpret it in code so you can follow. So in that, if you want to create a class, you see, use the class keyword. Like the analogy we're following, we say class person. If you want to create a class, you start with a capital letter. If you use person, you can still use person, but for the convention, in that convention, we use the uppercase. Here we create a class person. Let's see, the person can have a name, right? Let's say it's a nullable string name, because here, if I don't put this question mark here, we are basically saying this name cannot be null. That means it's waiting for us to instantiate to initialize name here. It's waiting for us to give name this thing. It's waiting for us to give
Divine name
a value. Yes, let's say name Jamming here, but we don't want that. We don't want to give name a value here. Is when, hold on, let me get to this name first. I said all programs should run in our main function, right? So we can instantiate person like this. Let's see, var p is equals to. This is how we instantiate a class. Just like you are calling the function. When I talked about functions, you call a function with this opening and closing parentheses. So we have created an object. I want you to get English now. We have created an object from this person class. So this is what we use a class for, to create instances of this person class. We create an object. So now P is now a new object of type person. If we hover around P now, you can see P is of type person. I said if we use var is going to infer the type inference, if you can remember. So we can even use person here instead of var. It's still the same thing. But we can use var to infer the type. So P is of type person now. We can create as many instances of person we want. You can see another instance. Let's say, okay, let me call this one here, Jamming. Hold on. Var Jamming. This Jamming is a new person, right? We have, let's say, var Olaliko. You can see I'm not using capital letter to initialize the variable here because it's not a class. We are not initializing the class with var. If anyone wants to initialize the class or want to give a class an identifier, we use the uppercase. But if we are just declaring the variable, we use the lowercase. It's another person. So these are two different persons. She can see. there are two different objects. If we print, let's print Jamie first. Let's print Jamie to tell you it's an instance of a person. Hold on. So run this code now. We can say that one. You know, the other time I said you have to specify the name of the file, right? The name of the library. But remember, we cannot just specify the name of the library, right? Because now the library is inside another folder. It's inside this OOP folder. So what we can do is say that from OOP / then we can now reference the name of the file. OOP.dat. So you can see it's telling us, because we printed what Jamie was. So it's telling us Jamie is an instance of a person. So you can see is one instance, is an object. This Olalekan too is its own instance, a different object. So you can get now. So we can keep creating different persons from this class person. So that's why we need a class. We can keep creating as many persons as we want from this class person. So like I said the other time, a person can have a name. So you can see why I said we shouldn't give name a value here inside the class. If you can just look at it now, we shouldn't give a name. We shouldn't give the name inside the class, because if we reference Jamie now, Jamie's name will be, let's print Jamie.name, because this is how we get the value from the class. So we use this dot notation. You see, I'm saying Jamie.name. So we use this dot notation to get a property from the class. So to get Jamie's name, we use Jamie.name. Is this name here? So if we print Jamie.name, it's going to give us Jamie, right? Because the name here is Jamie. So you can see. But now I want to print Olalekan.name too. Let's see, Olalekan.name. You see? Olalekan.name too is giving us Jamie. But do we want this? No, we don't want this, because Olalekan is its own different object. Jamie too is its own different object. They are just instances of the person class. So what we want is that whenever we want to create a new object, like want to create a new object from the person class, we want to supply that property. It's only then that wants to supply that property to the class. You get? It's only when we instantiate the class that want to give it the name. Let me say it slowly. It's only when we instantiate the class that want to give it the name. You know, here we are giving the name, the value here, but in every class, name will still be Jamie. But we don't want that. We want Jamie, want to give the class a name only when we instantiate it. So the way we do that, here we can say, right now, name is null. Let's just say name is null right here. So whenever we want to instantiate Jamie, we can give Jamie a name. You know, I when we were talking about variable declaration, I said if you use the var keyword, it means the variable is mutable, meaning you can change it. So here we can say Jamie.name here should be Jamie, right? And then here, and again, you know, we have created Olalekan here. Then we can say Olalekan.name is equals to Olalekan. So now here, if we print Jamie.name and Olalekan.name, you see, it's printing Jamie and Olalekan like we wanted. You see, because we are changing the property of name after we have instantiated it. So you can see. So we said a person can have a name, a person can have an age, a person can have an height, so remember, if we don't give the value, you know, here we've supplied that Jamie.name is now Jamie. But if we reference age, let me print Jamie.h for you so you can see. If we reference age, age is null because we've not given it a value here. You can see it's null because we've not given it a value. So we need to give it a value so it will not be null again. So if we reference jami.age somewhere in our program, it's going to crash our program because age is null. But there's another way. Instead of us now supplying the property after we have instantiated the class, there's another way we can do this. We can supply the property as soon as we create the class. We use this thing called a constructor. So we use this thing called a constructor. A constructor is like a function that will get called automatically as soon as you instantiate a class. There's something I didn't mention previously. There is a constructor being called for us by that automatically, invisibly, but you can't see it. It's because of that constructor that we can call a class with this parenthesis. You know that when I mentioned that if you want to invoke a function the other time, you need to use this parenthesis. So a constructor is a function. That's why we can invoke a person like this. The way we declare a constructor, we use the class name, and then it has a body. It's just like a function, but there's something that I want to point out here. You can see the name of the constructor is the same as the class name. So you can see. So that's how you know it's a constructor. So under the hood, the Dart programming language is running this constructor for us, even if we don't call it. So you see, it's running this constructor for us, even if we don't call it automatically. And that's why we can instantiate a class with this parenthesis. So now, if you can follow what I've been saying, I said a constructor gets called automatically as soon as you instantiate a class. As soon as you call a class, the constructor gets run automatically. So if you think about it, this is like the best place to supply the name and all that. Like this jami.me, this is the best place to give that value. Let me show you how. So for instance, you know a constructor is like a function now. So we can get the name here, its name, its age, its height. So now, when we call person, you can see it's giving us error here because it's expecting 3 positional arguments. It's expecting us to supply some arguments to it. You have 1, 2, 3. It's expecting the name, the age, and the height here. So it's inside this constructor that I want to initialize all these variables, all these fields. You know, I said all these things, they are like the properties of a person. So a person can have a name, age, they are like the properties. We call them properties or fields. So we can initialize these properties inside the constructor. So now I want to say this name. So if you want to say this name, you can say name is equals to this name that we are passing here. Name. But because of ambiguity, you don't know which name we are referencing here. We can use this keyword they call this. So this dot name refers to this class's name, this name here, this field. So that's the this dot name. Oh, sorry, name is a string. I made a mistake here. Name is a string, not an integer. So we are saying this name should now be equal to the name we are supplying through the constructor. So we can do the same for age. I say this dot age equals to the age we are supplying, this dot height equal to the height we are supplying. So we don't really need to use jami.name to set the name again. So all we need to do now is whenever we want to create a new object, then we need to supply those properties. So it expects a string called name. So we have to say jami. It expects an integer age. Let's see, it's 1,000 years. Sorry, it's an integer. I'll be Methuselah. So 1,000 So height, I'm very tall. I'll say, let's say 300. So you can see it's not giving us the error anymore here. So now, as soon as we are creating the person object, we are calling the constructor. So now the constructor is asking for these parameters, the name, the age, and the height. And it's the constructor that will help us set that name that we are supplying the constructor. You see this Jami, we are supplying it here. So now we are now setting this class's name. That's why we're using this dot name. This class's name, we are supplying it. We are now setting the value to be that name that we are giving when we create the object. See the age, we are creating the age. The height, we are supplying the height. So now for Olalekan too, so we can create another person called Olalekan. His name is Olalekan. And see, age is older than 10,000 years old. Let's see, height is taller, 400. So you can see, we have created two different person objects. So this Jami is an object on its own. This Olalekan is an object on its own. But they are using this person class to create the object. So you can see. Now we can print Jami.age, we can print Jami. Height, we can even print Olalekan dot name. Let's print all this. Let's see. Jami.age is telling us Jami.age is 1,000 and it's right. You can see. Age is 1,000. Jami.height is 300. You can see it's right. It's 300. Olalekan.name is Olalekan. You can see it's written Olalekan. So now we have created a new object and we are supplying the properties through the constructor. So if you remember when I talked about functions, this constructor is just like a function. It's a function, you can see. So there is another way we can supply parameters or arguments to functions. Because here you can see the problem. We have to know the position because these are positional parameters. We have to know the positions of these parameters. But most times, you can be creating a class that another developer is going to reference, is going to use. So we shouldn't mandate the position for them to know the position. So to do that, we use these named parameters. To use named parameters, we wrap them in curly braces, like I mentioned the other time. So we can wrap them in curly braces. And because it's nullable, it's not giving us an error. If it was non-nullable, we would have used this required keyword. Required. But it's not nullable, we don't need it. Sorry, it's nullable, I mean. It's nullable, so we don't need it. Hold on. Parameter h can't have a value of null because we need that required keyword. So we need the required keyword. Required. We need to make everything required.
So please, why are we using the curly braces inside the constructor?
In the function class, hold on, I'm having problem with my VS Code. Okay, that's fine. In the function session, that session that we talked about functions, I talked about different ways we can accept arguments in a function. We can get rid of the curly braces. It will work just fine. But as you can see here, we have to know the position. You can see string name, int age, int height. We have to know the position when we are supplying the value here. For instance, if we mess up the position here, we say, okay, we don't want age to be here. Let's say we want to supply age here. There will be an issue. Why? Because the first parameter is asking for a string name, and we are supplying integer. Second parameter is asking for an integer, we are supplying a string. So you can see there's issues because it's positional. It's asking for that same type, string name, and we are supplying an integer. But we can we can just avoid this kind of issue by using named parameter. The one I showed you earlier, this one here, we call them positional parameters. So we can use named parameter by using the curly braces, by just wrapping the parameter in curly braces and then making them required. Let's make it required. So now you can see it's giving us error here now, because what it needs is it needs the name colon Jamil, age colon, and then height colon. So now it doesn't matter wherever I want to put age or name. We can even bring it, we can put it at the last. There will be no issue because it knows age is 1000. So it doesn't care now. It just finds out what parameter is age. Oh, this one is age. Now it gives it the 1000. Height, checks, oh, height, finds where the height is, and it gives it the 300. Name, finds where the name is, and it gives it Jamil. So now we can supply the arguments anyhow, any way we want it. It doesn't have to be this thing. How do I put it? It doesn't have to be.
Okay.
There was a word I used for it initially. I've forgotten. I don't know. Initially it has to be the name has to be a string here without the curly braces. We had to supply the string here in the position, the first position, the age second position, and the height third position. So we had to supply it like that. But now we don't need that. We can just apply it anyhow we want because we are using the name. That's why they call it name parameters. We are using the name to supply the value like this. That's why we are using curly braces, because most time in your Flutter application, you see people using these curly braces in functions, because this constructor too is a function. You see these curly braces to collect arguments in functions, because we don't want to keep remembering the order. That was the word I used for it. We don't want to keep remembering what order did we place our arguments. So this curly braces is just helping us. We can place the arguments any order we like, in any order we like. So that's why we need this curly braces here. So I mentioned this when we talked about functions. If you go back to that video, maybe when we finish this session, you can go back to that video to reference. So now for Lalecon now, we need to put the name. So name, we need to put the parameter in age and height. So there is no issue anymore. So now we can create any person we want. You can see we can create any instance of a person we want. So this Jamie is a different person. This Olalikon is a different person, but we are using this class to create these objects. So Jamie is an object. Olalikon is an object. And there's something I didn't mention initially. I've been mentioning this since the beginning of that tutorial, that every class in that extends the object class, inherits from the object class. By default, you can't see this, but this is what happens. I think I'll talk about inheritance in the next class. I don't know, depending on the time. I might talk about it in this class, but this is what inheritance is. Every class in that extends the object class. The string, the into double extends this object class. We'll talk about this extend keyword later in next class or this class, depending. Just know that every class extends or inherits from the object class. So the object is a class, so we are extending the object class. So Jamie is a new object. Olalikon is a new object. Initially, before the early days of that, if we want to create a new object, we use this new keyword. We say new person or new person. But the new that we have now, you don't need it. You don't need this new keyword. Because in some other programming language, you come across something like this: new, then instantiate the class. It's just to let you know, because what you are learning here, you can apply it in other programming language. So if you want to pick up C# or Java or something like that, it won't be new to you anymore. So that's just the idea behind object-oriented programming. It's just to model things you can see, things you know. Just model them inside the class that I can then reuse, that I can create objects from. So we have a person, we are creating objects from this person, right? So let us think about something else we can model. We can have a class called car, right? Can have a class car. So you can model the car. You can say the class you have a name, right? String name. Don't forget, can be nullable. Something else I didn't mention. Here I said is a nullable string called Jamil. Anytime if we don't supply the value, name will be null, right? We can use final. In the world, you see people using final here to initialize, to declare a variable in a class. So we can use final to declare this variable here. You see final string. If we use final here, now it's asking for a constructor. Because it's expecting us to initialize the variable inside the constructor. I'm saying final string name. So name is non-nullable. We can make it nullable. But even if it's nullable, it's still expecting us to initialize it in a constructor. So if we use final in the world, you see people using final a lot. Remember, I mentioned there's a difference between final and const. Final is a runtime constant, and const is a compile time constant. What this means is that when we create a new object from this car, and we are supplying the name, we are supplying the name. Okay, let me supply it. Hold on. We have to create a constructor, else we will keep having this error. So to create a constructor, remember I said we have to use the name of the class like a function, right? So we have a constructor, and it's expecting us to initialize this name. You see, the error is no more there. In car is expecting us to pass in a name, because here we are specifying name here. See, if we don't ask for name, there will be no error. But it's expecting name here. So in the constructor, you should ask for a parameter. Now we are using a positional parameter, right? Because we are not using curly brace here. Let's say string name, and then we can say this dot name is that name, right? Hold on. Let's my Visual Studio Code do its rubbish. I mean, it's because I'm running a lot of stuff. Let's give it a moment. Please hold on. I think I have to restart my VS Code again. Hold on, let me restart my VS Code. So remember I said final. Okay, let me get rid of this. I said final is a runtime constant, and const is a compile time constant. So I differentiated between runtime and compile time the other time. I said runtime is when your code is already run, it has finished compiling. Compilation means the computer cannot understand English, cannot understand this code we're writing. It only understands binary, zeros and one. So this code we're writing has to get compiled to zeros and one, which the computer understands. So that is compile time. When the code gets compiled, gets translated to zeros and one. So that's compilation. So our code has to get compiled first before it gets run. So it has to compile before the computer understands it and run it. So during compile time, if we use const is a compile time constant. That means once you set the variable, once you set the value, you can never change it again. But if you use final, you can change the value only once while the program is already running. So if the program is still compiling, you can still set the variable as many times as you want. But if it is running, you can only set the variable once. So why I mentioned that is that here, here we are creating a class car, right? So if we run the program, this car is going to get compiled, right? And we are using the final keyword. The name variable has not been set yet. So the only time the name variable will be set is when, we call, let me get rid of this constructor first. If I get rid of it, it's going to scream at me. The time we set the name of this car is when we instantiate the car class. Let's say car. I'm not capturing it in any variable right now, but let's say car, and let's apply the name. Let's say Tesla, right? So now, if we set the name Tesla to Tesla, Abi, so now Tesla becomes constant. We cannot change the name again. So that's the difference between when we use const and final. Let me make this code run because so the issue is telling us here is we cannot, we said it's final. We cannot now change what a final variable is again inside the constructor body. We say this dot name should now be the name we are setting to it. Remember, we are using final, right? And we said we can only set it once. The constructor, when we compile the program and when we run the program is already running, and name will be set to null. Let me come back. When we compile and then run, the program will run and name will be set to null already. So that will already happen before the constructor body, before this function body gets run. So that's why we're having an issue here. We cannot set name again inside the constructor body because it is final. See again. We cannot set the name again inside the constructor body because it's final. The way we can set it now, there's a hack. The way we can set the name is if we use this thing called initialization list. We use the initialization this thing by using this colon. So use this colon to initialize this variable before the constructor body gets run. Remember, we can still use the constructor body. Let's get to this semicolon. We can still use the constructor body to do anything we want. Maybe we want to initialize something else. We can still use this constructor body. Let's say speed. The speed should be double. Let's not use final here. Let's say double, and it should be nullable, double speed. So we can still initialize speed here. That means we have to supply speed in the constructor parameter. So double speed. And then here in the constructor body, we can now say this dot speed is now equal to the speed we provide. So now here is asking for the name and the speed. Let's see, it is let's see 160.0. All right. So let's see, this is the speed, is the name. So now you can see we are using the final. That means we need to set the variable before we enter the constructor body. So I think we're running out of time again. So for as long as we have so many fields, what else? What are the other property can they have? For as long as we have so many fields, then we can pass them into the constructor to initialize them. So we can use the initialization list if we're using final. That's why we're using this colon. We can use the initialization list. But if we're not using final, we can reset the value of that field, of that property in the constructor body. So this speed is null. Here too, we're not supplying name. Name is null here. And then in the initialization list, we are supplying the name. You cannot bring it. You cannot bring it in the constructor body because the code has already compiled and is already running, and we have already set name to null here. We have set name to null, so it's not possible anymore to reset name again. Now name becomes immutable. You cannot mutate name again inside the constructor body. You can only do that in the initialization list. So we initialize name here. So we can even initialize speed here instead of the constructor body. You can initialize speed here if you want. You see, can still initialize speed here, and then we can do anything else. Let's say in the constructor body, we can print. Let's just print constructor called. That's just what you are doing in the constructor body. You can even get rid of the constructor body if you want. I would just need a semicolon. You can get rid of the constructor body. You just use a semicolon to indicate that we are done with the initialization. But so we can do anything, we can still do anything we want in the constructor body. So let's call, okay, this is a new object, a new car object. Let's store it in a variable called Tesla. So if we print Tesla dot, okay, hold on, I'm not printing. Tesla dot name. So what I'm expecting here, I'm expecting two print statements. I'm expecting this print statement because remember I told you the constructor will get called automatically, right? And in the constructor body, I'm printing constructor called, and then I'm printing Tesla.name. So let's run this code. So you see, it's printing constructor called and then Tesla. So we can do anything we want in the constructor body. But if we like, even if we like, we can get rid of the constructor body. It doesn't stop our code. It's just not going to print constructor called again. It's just going to print Tesla.name. You see, Tesla.name is Tesla. And remember, we can use the curly braces to specify that we want a named parameter, and then we use the required keyword, the required annotation, to specify that these parameters are required. So whenever we instantiate a car, whenever we instantiate this car class, we are required to supply the name arguments, name and speed arguments. So here, because we are using named arguments, we specify name, because the name is Tesla, and speed is this 160.0, and there's no issue. There's no issue. So we've talked about fields and properties. We can call them property because they are properties of the car. We can call them fields, and then we talked about constructor. So there's another way to use the constructor, but I don't want to clutter this file too much. You know, that's why we created a new folder called OOP. So in this OOP folder, you can click on it, so it should be shown. Click on the OOP folder and then create a new file. Let's call this constructors. That's the constructor.dat. We can do that. So I can continue, right? Hello, are you still there?
Yes, you're still here. We can hear you.
All right. So constructor. So if you check the left pane, you can see that they are indented. These folders inside the OOP, these files inside the OOP folder, they are indented to show you that they are inside the OOP folder. So if I click the OOP folder again, you can see. So they are inside. If I expand the OOP folder, you see the files inside. So if you want any that program that we want to write on OOP, we'll be putting them inside this OOP folder. So now we created a new folder called constructor. So we've been talking about constructor before too. Here, this is a constructor, right? I said the constructor will get called automatically anytime you instantiate, or anytime you instantiate a class, the constructor gets called automatically. Even if you don't specify the constructor, the Dart programming language generates a default constructor for you and to run it. So that's why you can instantiate a class. So now, let's say class quadrilateral. Quadrilateral is like a 2D plane shape that has 4 sides, right? If I'm not mistaken. Hold on. Give me a moment. All right. I hope I'm recording this session. Okay. So here we have a class called quadrilateral. Let me think of fields we can have. Let's see. Okay, let's see. Int. Let's use final here. Let's say final int L for, let's just say L for length. Okay, let me use length. Let me see breadth. So now, if you want to create a constructor, we'll use, I told you, we'll use the name of the class, right? Then we use it like this. There's another way. To, without typing all this code, typing quadrilateral and doing all that. There's another way. We're downloading extensions the other time. When we downloaded the Flutter and that extension, awesome snippet and all that. So this is where it comes in handy. So you can just click on any of those properties, right? Click anywhere. You don't need to alight. Click anywhere on any of those properties. You can then hit the control key. Don't release it. Hit the control key and then the period key. That is the dot. You should bring out all this drop down. You see this one that says generate constructor. If you hit on it, it automatically generates a named parameter constructor for you, and it's giving them required just like we did initially. But this time around, the last time I told you we have the constructor body, right? The constructor body here, and then we can use the initialization list to initialize whatever parameter we passed to initialize the class, right? There's another way. Instead of doing all that, instead of using that initialization list, and saying length is equals to whatever the length we passed or something, or even just using the constructor body, right? Instead of doing that, there is something we call syntactic sugar. The Dart program engineers has given us a syntactic sugar. Instead of doing all that, you can just use this inside. Let me get to that so you can see it clearly. Instead of going through all that, hold on. Let me just show you what we would have done instead of this one. We have said quadrilateral. Let me comment this one out. Then we would have, let's say we are using name parameter. We would have said required int length, right? We would have said required int breadth, right? And then we would have used the initialization list to now initialize length. Sorry, So initialize this dot's length will be the length that was supplied in the parameter, right? And they would have said this dot's breadth to be the breadth we supply. We would have initialized it this way. So you can see this is kind of cumbersome and clunky. So the data engineers gave us a nice syntactic sugar instead of going through all this, receiving the parameter and then initializing the variables, the fields. Instead of doing these two steps, you can just do them in a one-liner, call it one-liner. You can do it in one line like this. Here you see. Let me comment this one out. So what I wrote here is the same thing that I wrote here. The same thing as this one here. So you can see here, we are saying we are still using the required keyword. We are now saying this dot length, this class's length should be the length we supply when we instantiate the class. So when we call the classes constructor. So this is the same thing, this one, the same thing as this one. So you'll be seeing this syntax a lot in the world because it's saving us a lot of time typing some boilerplate code. So this is what we call a syntactic sugar. It's just to save us some typing. So you can use this, you can use this. But if you ask me, this is kind of better to me because it saves me some typing. And now I can read it. I know that, yeah, this is a constructor. It's expecting a length, and then we're passing the length. And it's setting that length we're passing to be the class's length, setting the breadth we are passing to be the class's breadth. So whenever we create a new instance of the class, of the quadrilateral class. So from now on, you see me use this syntax to create a constructor. So that's the constructor, the basic constructor for you. So we have other types of constructors. We call them named constructor. Let me come back. We call them named constructor. So for now, we're talking about quadrilaterals. Quadrilaterals are like 2D plane shapes that has 4 sides, right? So we can say, okay, we don't want to use, we are saying length and breadth, but if you can remember, the square has the same size, right? All the sides they are equal. So we can say, so if we want to instantiate a quadrilateral, we want to use this constructor to tell them that we are instantiating a square. We can say quadrilateral dot square. So we can receive. We can name it anything. We can name the parameter anything. Let's name it sides. So we can name it anything. So now we can just say in the initialization list, the length, sorry, this dot length. I'm not using the initialization list. This dot length should be the size, right? And then this dot breadth should also be the sides. Since a square has like this, all the sides are equal in the square. So that means if we want to create a new, instance of a quadrilateral, let's just see var f is equals to, if we use just a quadrilateral, we can supply the length. Let's say the length is 23, the breadth is 56. So you can see that this one is like a rectangle, right? This one is like a rectangle, but we can decide to use this other constructor instead of using this one, instead of using this normal constructor. And decide because we know that we are going to supply a square, right? We can use this constructor. Let's see, var square is equals to. Now we can now see quadrilateral. You can see it's even giving me some distance. can say quadrilateral dot square. Now we only have to supply just one side. If we say 20. Now, is this, if we say quadrilateral dot square, this is the constructor that will be called for this object. You know, this is a new object. This square is a new object. For this object, we are calling this constructor. We will not be calling this one. We'll be calling this one. Because we are using the named constructor, we are using the quadrilateral dot square. But for this one, we are calling the original constructor. So that was about, you can create as many named constructors as you want. You can even say quadrilateral dot zero. And this one is just to instantiate everything to 0. This dot length to be 0. This dot breadth to be 0. So we can use this constructor. This one is just, it will initialize all the fields, the length and breadth to be 0. So you can use as many named constructor as you want. I hope you can get it. So if you don't use the name constructor, you'll be calling this constructor that is specified here, the original constructor. So that's the difference between the name constructor and the original constructor. So now the next thing we want to talk about are methods. Methods. Let's create a new file for that. Click on the folder, call it methods.dat. So let's create void. Let's create a class here. Let's say class. Let's continue with our person class, right? Our person class. So you said a person has a name. Person has an age. Let's see final. There is this class, color class, but you have to import it from the that UI library. Hold on. Let's see color complexion. Hold on. Hold on. I've forgotten the. Oh, I don't think it's in that. It's in Flutter. I'm sorry, it's not in that. Let's use string. Let's use string. So now remember, I said we can use these snippets that we installed as an extension by clicking on any of the fields and then hitting the hitting the control key and then the period. Sorry. Control and period to bring out all these drop down. I can click on generate constructor. Exactly this one. Generate constructor. It's going to generate a constructor for you. Required this.name. So it is automatically initializing whatever we pass into it. So you can see the syntactic sugar I mentioned initially. So it's using that one. It's using that syntactic sugar. So now whenever we want to create an instance of a person, let's see, like var selling, we have not used selling person. So you can see, let me go back to it. You can see what happened. When I just typed P, it's giving me all this intelligence because I've created a class called person. If I click on it, it's going to automatically fill this. So it's prompting me to supply the name. Let's see. Sorry. The name is Salim. the age. The way I switch from that part to the other part, I hit the tab key. Let's see, 50. If I hit the tab key, it's going to go to the next one. Complexion, let's see, and complexion is a string. Let's see, dark. And so this is a new person, right? So we've talked about fields, we've talked about constructor. I said the next thing we want to talk about now is methods. So methods is like the verb. You know, these fields are like the nouns of the person, like the name, the age, the complexion. Now I want to talk about the verbs, what the person does. We call them methods. That is what you can do on a class. The method a class can perform. So a method is like a function. It's just a function inside the class. This is just technicality, it's just English. A method is just like a function, but a function that is inside a class. So the function, that function belongs to that class. That's why it's called a method. It's called a method of the class. Let me come back again. If we have a method here, let's just say void say I, and it's just going to say print I. You know, this is a function when we were talking about function. Remember, it's not inside anywhere. It's not inside the class, and it's not inside the main. It's just on its own. So if we want to invoke say I here, we will invoke say I by using the name say I with the parentheses to invoke the function. So if you print say I, okay, now it's not intro to OP, it's methods dot that. Method dot that. So if we run it, so methods, not method. So it's printing say I. Now this is a function like we've discussed. Now, if the function is inside a class, see, if the function is inside a class, the function becomes a method. The function is now a method of this person class. So now a method has access to the properties and fields. Here we can just see print hi name. We have access to the property. You can just see, okay, let's say hello and the name. So now, if you can remember, we created this person class called Selim. Now we can just say Selim, and we will use the dot notation. Selim dot, let's say I. Say Selim dot say I. It says hello Selim, as you can see. Let's create another person. Olalekan. Right. So if we just the print, how am I running the wrong one? You see, hold on, I'm printing Selim.ci. I want to print Olalekan.ci. As he's saying hello Olalekan, because this is the new object. We are referencing the say I method from the Olalekan object. So you can get it now. So the method inside the class, we call it, the function inside the class, we call it a method. So a method has access to properties in the class. Like we were saying, we were talking about quadrilateral the other time. Here, let me just quickly copy this. Quadrilateral. I think I'm spelling it wrong. What's in this one? Oh, yeah. It's quadrilateral.
The R is missing. R, yeah.
All right. So you see what I did? I clicked on any of the property, control and period to give me this drop down. And I hit the generate constructor. So now it's generating the constructor. So now we can just say find the area. What it will just say, just return the length times the breadth, right? I want us to print it. Let's just print it here instead of returning. So if it's printing, you know it's not returning anything. That means it's returning void. So let's just get rid of this return statement and then print. So yeah, if we create a class called Q using the quadrilateral class, let's say the length is 31 and 32. Let's say the breadth is 12. Just come up with any name. So now we can now call the area method on the quadrilateral class. We are creating a new object here. Q is a new object instantiated from the quadrilateral class. You can say Q dot area, and it's going to get the area for us, and it's going to print it. This is printing 384 because we supplied 32 and 12, so it's getting the area. The area is 32 times 12. If you do that, you see the answer is correct. 384 is correct. So we can create as many methods we want here. Any method you can think of. Like in the person now, we said the person can say I. You can say the person can jump, or let's say the person can walk, and it's just going to print now I'm walking. So it's giving me error here because we are using a single quote to create strings here. So it's not going to allow me to use another quote in between. You see, to the Dart programming language, this is the opening quotes and the closing quotes. So this one is just another, is like we are referencing the variable which is not existing here. So that's why it's giving us an issue. Now to get rid of this problem, there are two ways. You can use a double quote here and close it with double quotes. There will be no issue. Or you can use a terminating character, or how would you call it? By using the /, then there will be no issue. So now, if we go and say Olalekan dots walk, Olalekan dots walk, we're going to print now I'm walking. Okay, let me print it. Let me use the name. Now name is one. Okay. So you can see the object we are running. You can see saying now Olalekan is working. If we had used Selim, so I've said Selim is working because it's a class on its own. Now Selim is working. So you can see why we need classes and objects and all. It's just to group, it's just to model your data as an object. So if you can think of anything, you can make it an object. If you think of a chair, like I just think of a chair here, a chair can be of this length, it can be of this color and all that. So if you can think of anything, you can change it, can make it into an object. And like all this WhatsApp, if you want to create a mobile application like WhatsApp allows you to send messages. So even a message, you can make a message an object. If you make a message an object, so you can see, Let's say class message. So if you think about it, the message will have, let's say it will have a sender. Sorry, to have an ID. To have a string. Let's say the sender's name. Let's just say sender. You should have maybe this time. The time. You should have, yes, I've not mentioned this before. This date time is another class. To get your date time, you can see, go over around it. To get the time we are in right now. For instance, let me print date time dot now so you can see. Let me print dates. So the date time too is an object. Hold on. I think I'm having. Print date time. That's now. So the date time too is a class, and it has this now constructor. So when I said that is open source, you can just basically drill into whatever class or any functionality you see. You can drill into it and check how it is being implemented. If you want to check how it is being implemented, just make your cursor be anywhere on that this time. Control, click on hit control. You can see it's highlighting something for me. Now if I click your mouse, it will take you to that class. So you can see class date time. You know what this implement keyword means in another time. We're not tackling that now. You can see the date time is a class. It's a class. If we scroll through, we see where it says now. You can see we have datetime.utc. You can see datetime.now is a constructor. So you can see it's a constructor on its own. So if anything is not clear to you in the Dart programming language, just control and click to take you to the source code, to how it is being implemented. So if we let's print datetime.now so you can see what I was talking about. So it's printing this current date and time. If you check your time, it's correct. At this instant, at this time that I printed it, is correct. So this datetime.now is used to get the current date and time in that. So it's just, I'm just digressing a little bit because I used the datetime class here. So you know, I'm saying a message can have an ID, a message can have a sender, and the message can have time. So this is basically an object modeling what a message should look like. So you see, can generate our own constructor for it. Generate constructor. So we are modeling what a message should look like. So you can think of anything entirely to model an object, any object you can think of. Now a class can even take in other classes like this one. You see, I'm using datetime here. I can create another class that uses this message class. Like let's say this person too should have a message. Final message. You can use the message client type here because we have defined the message class here. So you see final message to the message. And still click this to help us generate. So it will add that this was message. Or it is asking us to supply the message here. If you want to supply a message, you need to use message. You need to use the message class. Let's create a message before we use it. File message is equals to. Let's give it an ID of any random ID. Sender. Let's see. Let's just use sender, and time should be datetime.now. You have to call it. You thank God now. So now we can now use this message. You know, we have created a new instance of the message class. And because this person object, you see, the person object is expecting us to pass in a message whenever we instantiate it. So here we can pass in that message. You can see, we can pass in the message. We can create another message, but let's just use that message here. So, to be that message that we created. So, and don't be confused. This message is the name constructor here. You know, the name constructor is expecting a message name. And the message we are passing, this is the message in the constructor. The message we are passing to it is this one we created here. You see, we are creating a message object here. That's what we're passing. That's the second message. So if we print Selim.message here, it's not the function. Selim.message. Let's print. Okay, our ID is expecting. This is why that is good. With that programming language is type safe. Don't even allow us. You see, it's expecting the argument type string can be assigned to a parameter type. If you read the error message, it says at line 2. The error is at line 2. You see. So if we scroll to it, see line 1, line 2. This is where the error is coming from. Because we are supplying the message ID here. We said it should be an integer. So here we are supplying the string. I did not even check. It's not even allowing us to compile ourselves. See, the argument type string can be assigned to a parameter type. So we can just get rid of the quotes to make it an integer. And then we are good to go. So that programming language is type safe. I think I'm not printing it. Selim.message. Hold on. There's another class we didn't even, there's another property we didn't specify. You know, a message has an ID, as a sender, has time. We don't even specify the message itself, the string itself, which is the message. Let's name it message. I'm looking for a name to give it because I don't want to confuse you. If I say message 2, you can be confused. Which message?
I said body.
Yeah.
Body. Body.
All right. Yeah. We can use body. We can say payload. We can say, yeah, let's use body. Thank you for that. We can generate our constructor, see, body. But then we have to supply the body here. So because it's a name parameter, we can put it anywhere we like. Let's put it in body. And let's say the message is hello, bro. Let's use an emoji. All right. I'm saying hello, bro. So this is the body. So now here in the toString method, we can print the body. I think we are running out of time. Body. So I'll tell you what this is doing. Hold on. Why is it not running? Oh, my bad. I'm just calling Selim.message. I'm not printing it. Let's print it. Let me get rid of this one. It's telling us it's an instance of message. We wanted to print Selim.message. Remember, message 2 is an object on its own. It's a class on its own. It's an instance of message. Now to print what is inside this message, we have to override. We'll talk about inheritance and polymorphism in the next class. But we have to override the toString method here. So we want to say, whenever we want to print message, we want to print this message class. If we print this message class without this toString method, it will just keep saying instance of message. We want to print what is inside. Say again, want to print the properties of the message, not that it should be printing instance of message all around. Want to print the property. Now we'll override the toString method because this is what we want it to print. We are just basically telling it if we print message, we want it to print this thing. We are saying print body and print. Let's just print. Sorry, fine. So if we anytime we print message, it's going to print body and then the body, time and then the time. So if we run this now, see, body is hello bro, because that's what we specified here, right? And this emoji. And then the time we created the objects. That's what it gives us. 2101. So it's printing hello body and hello. If in the toString method, we can even print the ID once. ID. So don't forget, this $sign is used for string interpolation. It's used to evaluate the value of something. So we are just saying ID here. That's why it's given. So we are just saying body here. That's why it's printing just body as a string. And then this $sign body is to evaluate whatever body is and return it as a string. So that's why it's returning whatever body is, which is hello bro. And then time, the string time, and whatever time is, which is here. So now we want to print the ID too. So anytime we print something.message, we should print body, time, and ID. So you can see it's printing the ID here. We'll get to inheritance and polymorphism in the next class. You see why we are using this override keyword, and then why we can use the toString method. The reason is because automatically it is extending the object class. You won't see it. Everything in that extends the object class. And in the object class, we have a toString method. We'll get to this in the next class. Let's control and click. You can see. So this is the implementation of the object class. You can see class objects. Everything in that extends this class. If we scroll down, you see toString. So we are using this toString method. When in the next class, when we talk about inheritance, we'll go deep into that. So today I just wanted to touch on intro to classes, what classes are, how we declare a class, how we create objects from a class. Talked about constructors, the different types of constructors we have, how we pass parameters from constructors from when we instantiate a class through the constructor, how we pass parameter to it. We talked about named parameters, positional parameters. And what else? Yeah, we talked about named constructors too, and the default constructor. Yes. And then we talked about the properties or the fields. We call them fields or properties. So this thing here, call them fields or properties. Then we talked about methods. This is like the action that we can do on the class. So like this toString too, you can see is a method. It's a method in the class. So it's an action that we perform on the class. toString is printing for us. It's telling us we are kind of modeling how we want the message object to print its properties. So in the Codilata, you can see we created an area method to just print out the area of its properties. Here too, we are creating the CI method, the work method. So we talked about the methods and all that. So I think this is the end of the class today. If you have any question, you can ask. If there's anything not clear, and ask so I can just rush back to.
So I don't have any question. Please, where can we see the video?
Don't worry, immediately after this
Where can
class.
we get the video?
Don't worry, immediately after this class, I will try to upload the video. So maybe today, tomorrow, you should see it.
On where?
YouTube now.
On where?
I've been uploading all the videos on YouTube. If you check,
What is the link to the video?
if you check the Slack channel, you see videos. I've been posting the videos every time. I've posted even the last class. So have you not been getting it?
I've not been seeing it.
You've not been
But
seeing
I'll
it.
check now.
Hold on, let me
I've not been
just,
checking. I've not been checking really.
all right. Let me just check.
Is
one
that
of-
I've not been checking, not.
Okay. So if you check the Slack channel, you see the videos. If you just scroll, I've not even gone for. If you just scroll a little bit up, you see one of the videos I posted, and then you see all the videos, even from the first class. Like when I started recording sessions, you see those videos there in my channel, my YouTube channel. All right. Salim, is there any questions? Hello, Salim.
No questions for me.
All right.
No.
So from
I'll
the next
go
class,
over the video later though.
okay.
Thank you very much.
All right, no problem. From the next class, we just talk about polymorphism, inheritance, maybe abstraction, maybe, and then encapsulation. Those are the four basic pillars of object-oriented programming. We have inheritance, we have polymorphism, we have abstraction, and then we have encapsulation. So we'll touch a little bit on each one of them in the next class. I'm kind of rushing you guys because we are way behind the timetable. We are like a week behind, like I mentioned in the channel. So I'll just be kind of rushing you guys a little bit. And then what I mentioned in the channel the other time about maybe trying to cover up. I don't know, we have to set a date. Maybe I'm 2 dates self because we have 2 sessions a week. We have to set 2 dates when we can just do those sessions to cover up. Or else we'll just keep rushing because we have to meet up. We are way behind. We should have started Flutter this week. And today is even Friday, the end of this week's session, and we've not even started Flutter. So you can see we are behind. My plan was to just start Flutter next week. So before the next week's session, which is Wednesday and Friday, I want us to take between tomorrow, which is Saturday, till Tuesday. We can pick between from Saturday till Tuesday, when we can have the 2 sessions we are missing. I don't know how we are going to do it. Maybe I'll just throw the question again in the channel. Oh, no problem. All right, thank you for joining the class. We'll meet in the next session. Can I end the session?
Thank you very much.
Thank you very much.
All right, no problem.
Yes, it's even going off now, sir. Let's down it.
All right. Good night. Have a nice night.
You too. Thank you very much.